So now we're going to move on to doing a deep dive into the report which was authored and published today, which is all about grand challenges in US manufacturing, findings and recommendations. So it's a great pleasure to welcome to the stage once again. Please join me in welcoming Sridhar Kota, the Executive Director of MForesight. Thank you.
Thank you, Ocean. First of all, Professor Shih, that was just so insightful for your presentation. I enjoyed it so much. So much to learn from each of the charts that you showed. And back in 2009, when we were making the case for manufacturing institutes, your article on restoring American competitiveness, I used to refer to it, talk about just every day. And that has significant impact on a lot of the things the previous administration has done. And then your book on producing prosperity. If you haven't read it, please do. There's so much. It's just amazing. So thank you. Yes, thank you. We got to sell more here than in China. That's going to be hard. We got fewer people anyhow. But thank you. And speaking of that, also I do want to thank Congressman Reed. Although I know he couldn't be here. Thank Andy Bakers for sharing his thoughts, sharing your thoughts. Thank you, Andy, for Congressman Reed for hosting us, a couple of weeks ago in the House Manufacturing Caucus. So I appreciate that. Also, I want to thank, Bruce Kramer's there. There you go. I do want to thank our sponsors, MForesight sponsors, Dr. Bruce Kramer from NSF, and appreciate it. And where is our other friend, Mike Molnar? He's probably coming in late, I think. Mike Molnar from Enlist. These are not only sponsors, but guide us in many ways. Appreciate that. Thank you. So now, let's talk about the grand challenges. I must tell you that these challenges, many of you heard, you talked about it, you wrote about them, not just last year, for the last 2 decades. We call them grand challenges for a couple of reasons. One is, by calling them grand, one is probably you'll pay attention. Number 2, the part of the reason is they become grand because we've been talking about them, we have never addressed them. They're just getting worse. So they become grand now. And the real, I would say the reason they've become grand is that, as I mentioned earlier, this innovate here, manufacture there, this paradigm we've been living for the last 2 decades. Like I said, it's now becoming an innovate there, manufacture there. I think that's a dangerous trend. That is the grand challenge. And that's what I want to give you an overview. Innovation moves faster here. They're talking about China, not here. So the erosion of our industrial commons. We've been talking about it for quite some time, but now it is limiting our ability to manufacture new advanced technology products. We can do all the great R&D, great ideas, great product ideas, process ideas, but when it comes to scaling, we know how to do it, we know where to do. And it's obviously China is the right answer, or Asia in general, not just China, South Korea, Japan. That's where the real know-how is. And that's happening right in front of our eyes. In the report, we talked to you about some of those things. But not, again, as Willie said, not to depress you. We know all this stuff. The challenges we know, but we have some transformative opportunities, especially in this, what the digital, democratized, and distributed manufacturing. That plays to American strengths, and you'll hear more about that in the next keynote by Mr. Moret. But also there are other things such as the large capital markets and great R&D and other capabilities. They play to our strengths, but we need to have a strategy how to leverage that. Otherwise, we'll just keep talking about these challenges. We'll come back another 10 years, write another report. So what we've done is, we know that for the past 9 months or so, we've done a lot of data and analysis on a lot of these topics on our innovation ecosystem and venture funding and R&D investments and so on and so forth. And more importantly, we held these roundtable discussions, as some of you have participated, many of you know. We've done these roundtable discussions around the country in those cities that are listed there. And we put together, we assembled these thought leaders. And I did want to point out the CA report appendix. Please do take a look at the list of people who are participating in this I mean, every one of them, they know what they're talking about, their years of experience and wisdom. And so these are the people we assembled. And we just didn't do a lot of PowerPoint. In fact, we did very little or nothing at all, other than 15-minute overview. We spent over 1,000 hours, far more than 1,000 hours of discussion time on what to do, not admiring the problem. So what do we do? That is what we captured in that report. So let me give you, and then these are just the 3 questions we asked around the table. How do we regain our industrial commons, and particularly in reference to defense supply chains? And how do we create wealth from our R&D investments? And how do we ensure financing for hardware startups and scale-ups? These are the only 3 questions we asked, spent thousands of hours talking about. So, surely taxes, trade, and regulations may be necessary, or they could certainly enhance competitiveness of the current industries, existing industries. But it does very little to create new industries. There is something fundamentally missing, our erosion of our industrial commons. We are losing that manufacturing know-how, and so that's another facet, important thing that we need to address for national wealth and security. And speaking of security, somebody figured it out back in 1776. Adam Smith said, if you need equipment for defense, we can't rely on other countries. Well, it's common sense, perfect sense. A few hundred years later, a report came out, Senate Armed Services Committee. They got 1 million counterfeit parts today. I don't think they fixed it. The report was in 2012, but we still have the same challenges. And the most advanced work is no longer conducted in the United States. That is troublesome. And it's not just the March economic report or April economic report. Fundamentally, we have this major challenge. And import penetration in advanced technology. Here we are looking at the numbers. This is the import content of U.S. manufactured goods. Certainly, when you look at the bottom ones, locally processed goods and resource-intensive commodities, you would actually expect more like 100%, but they're not there. Overall manufacturing, it's about 50% of what we manufacture is actually imported components. But look at the technology-driven innovative products. We lost like 13 percentage points in just the last 15 years. That is a dangerous trend. And not only that, but we have erosion of our foundational capabilities. And the real value added, that hasn't changed much since mid-90s. If you look at the manufacturing without computers and pharmaceuticals, that hasn't changed much. It's about the same as what we were in mid-90s. And the rest of the countries have whizzed past since. And again, compared to, it's only 40% more if you look at all of manufacturing. Certainly, the China rise, and Japan and Germany also lost how much of global value they are adding. We lost 8 percentage points. Germany lost only 2. They have higher wages. They have a lot of their challenges too, but somehow they managed to do very well. And here is the innovate here, make there. This is just a picture I've taken. Think of that an iPod or an iPad, whatever it is. But the fundamental elements behind that, from the lithium-ion battery to display, the micro hard drive, signal compression, all of these technologies were largely invented here. But more importantly, the fundamental research, the science behind the knowledge creation was done by, you may not be able to read it, it's in the report, but the funding from Department of Defense and Energy and NSF that funded this. So we created that knowledge. Obviously, we haven't created wealth from it. And if you look at the cycle of innovation, we fund a lot of discoveries. We fund basic research, and rightly so, and we should do more of that to create these discoveries and inventions. But if you just do that, and then once the technology is proven, the funding dries out. We all know that. I don't know, if we just think about this as the baseball diamond, we just keep scoring singles, and sometimes we score a double. We hit a single or hit a double, that doesn't mean scoring. We need to do the entire go around the cycle of innovation. Otherwise, we are missing out on the process inventions, process innovations, that actually leads to the next cycle. Because if we don't manufacture today's products, we will lose our ability to innovate. And we're just giving up on that. We're just doing the first part. And we invest, $140 billion a year after year. And at the end of the year, we get, it's more like $800 billion, but who's counting a manufacturing deficit? It's not like we had to make every shoe and every T-shirt. It's not that. Actually, look at the advanced technology products. We have a deficit of $100 billion. If you're putting year after year $140 billion, you get that $100 billion tech deficit. We should have at least $1 surplus. And that's not too much to ask. And somehow we keep doing that. I don't know why we are not getting a different result. And so the challenge is leading the world in R&D is important, but it's little comfort if all we are doing is subsidizing R&D for other countries. And we are getting good at it too. If you look at it, back in good old days when you had MRI machines and robots and all that, we manufactured here and eventually we outsourced the components and the subsystems, and eventually it took a while before it moved overseas. Then when it came to laptops and flat panels and cell phones, there is not much of manufacturing here. We are losing it faster and faster. And when it comes to today's technology, flex electronics and nanotech, I put a question mark. I don't know. Are we going to do any manufacturing, scale manufacturing, not just prototyping? So by not doing that, again, by not completing the cycle of innovation, we are losing our ability to innovate, as I pointed out. And we used to do that back then, but now we are just scoring singles or hitting singles. And obviously, because the point of this is that we want R&D and manufacture to be closer together. That's well understood. So since so much of manufacturing is there, so the new trend is, well, let's move R&D over there. So let's innovate there and make there. So 45% of foreign R&D centers in China are from U.S. companies. And you can see that numbers, if you actually look at it, it's $44 billion. That's not much. The total $44 billion, we are about 40% of that. It's about 16, less than $20 billion. That amount is not a big deal. But the trend should be troublesome. And why are we moving to China for R&D? Why our multinational MNCs are moving their R&D to China? Here is the responses. The top 3 responses you see: proximity to high-growth market, because they know how to create demand, whether it's electric vehicles or whatever. Proximity to key manufacturing base, that's where the manufacturing is, that's where the key suppliers are. It makes perfect sense to go there, really. And then top 7 reasons, top 5, you see, they all correspond to the strength of China's industrial commons, including access to technical talent. So, as some economists talk about how we are the knowledge economy, why yes, they are a knowledge economy. They could do manufacturing and they are knowledge too. So that trend is very troublesome. And of course, we create a lot of IP, no question about it. Great work done at our universities and our national labs, federal labs broadly. If you think about it, for every $1 billion of R&D investments, 45 patents issued in the federal lab, and $4 million in license revenue. That's not much, but it doesn't matter. But that's what we do. And there are a total 2,200 patents, and the total licensing revenue, not per year, not in 2015, all of it is about $193, $200 million. But we invest $46 billion a year after year. Universities do far better than our federal labs. But, that's still, we all can do much better than that. So you have, $37 billion spent on university R&D, lots of patents, $1 billion total license revenue, $52 million is that particular year, 2015. Out of $37 billion, that's not how you spend your money to get return on investment. And then the VCs, they rarely invest in hardware, which nothing new. Again, like I said, these are the challenges They invest mostly in software and biotech for the reasons we understand. it's less than 5% of the VC money goes into hardware. So that is a troublesome about startups and then let alone scale-ups. MIT did a fantastic study on the production, PI study, production innovation economy. They looked at what lots of companies, 150 manufacturing startups. And finally, when it came to scaling up, you know the answer. The best way to scale up is to go to Asia. It's no wonder we are not generating wealth or national security from our investments in R&D. And, of course, the foreign participation in our capital market is also interesting. China is putting a lot of money into it, which you all know, in Silicon Valley. And not only that, we are actually in aerospace is one sector where we have a trade surplus. And as Professor Shi pointed out, the moonshot, the GE aircraft engine, it's not only the investment in basic science to Boeing, but also in the translational research in R&D to take it all the way to prototyping and production, something that government has invested. But anyway, the investments by China in our U.S. aerospace industry, take a look at that. Those are all pretty serious companies, not just a small mom-and-pop shop. So you're talking about the company's mergers and acquisitions. So that's another area, aerospace industry, where we have the strength. It may not last very long, so we need to be other guys are not just sitting around. So here are a few things. Tom and I could have filled 50, or at least 50 more slides, maybe 100 more like this. But I want to share with you in just 2 more minutes some of the things, what we learned talking to people around the country. These are all real examples. I can answer, their examples are in the report. Like flexible displays and nanotechnology. We met with people in our national labs, federal labs, and also at university researchers who have a great product when it's ready for prime time. We met with their partners from overseas, from Japan and South Korea, where they are actually, that is the right place to scale. So they made it. When it finally comes to scaling, they figured out the folks in Asia are best suited because they have the manufacturing know-how. And they explained it, and you would understand that is the right thing to do. So it's no one to blame, really, but just that we as a nation never had a strategy of what to do with our good ideas. So the point, this is one of the academics who said, once the technology is proven to work, funding dries out. That is so true. I put a parenthesis, yes, because that's what most researchers will agree. That once the technology is done, there is no science in it anymore, so there is no funding. So the leading academics, I know intellectual property theft is bad, we get that. But we are willingly giving it away to China. There are so many examples. These are just not words. These are actually real case studies behind each of these words. And there are many more. I put et cetera there. Tissue engineering, battery technology, predictive analytics. These are the things that NSF and DOE and DOD has funded tens of millions of dollars over a period of 10 years. When it finally comes to fruition, they can't get any funding here. They have moved. China has attracted these researchers with tens of millions of dollars. And you can't blame China for it. You can't blame the researcher for it. Because that's why they want to take it. So these are things that actually happened already and happening right in front of our eyes. So we are willingly giving it away. And, of course, you saw the items 4 and 5. You all read a lot about that. But also I want to point out, even in the multiple technology collaborative institutes from China, you could just do Google images. So you can see all of those. They have signed MOUs with many different universities, leading research universities, and targeting specific areas like bioengineering, medicine, advanced materials, and manufacturing. And this is to accelerate technology transformation to China. And universities are engaging in those MOUs. So these are all actual realities on the ground, not just words. So our large companies, multinational corporations in this country, they are driven by short-term financial incentives. Probably they learned it from some good business schools. And right, that's what they teach. And focus primarily on current product development. They need to do that to stay competitive. There's nothing wrong with it. But they do very little. They nearly abandoned any long-term research to get the best idea from university and then see how we can create the next big thing. That's been gone. It does happen in some sectors, from others. You pointed at Google and Facebook, and those guys are actually like the Bell Labs of today. In that sector, they are investing, no question about it, in that area. But beyond that, There's not much of that happening at all. I'm talking only about hardware right now. So only government can overcome this market failure for U.S. to be globally competitive. And government has a critical role to play in investing in manufacturing R&D and beyond. When I say beyond, it's not just, again, invest in R&D, mature the MRLs and TRLs, and then hand it to China. That's much worse than what we are doing now. They need to be able to, there should be strategy. There should be some coordination. We already have all the pieces in place in terms of not only taking the best promising technologies to the next stage from the national security point of view, but also coordinate what other buildings are doing in this town, coordinate with the early procurement by the Defense Department, and helping the export assistance. There are a lot of things that are in place, but we are not connecting the dots. So, by the way, in terms of investing, it's not just how much we invest, how much more we need to invest. We should do that, but what we invest in actually matters. Here is a quick example. Bear with me. This is 2016 OECD data. U.S. federal R&D budget, $140 billion. In industrial production and technology, we invested $773 million. Quite impressive looks on one hand. Their definition is R&D on industrial products and their manufacturing processes. Now let's see what the other countries are doing. If you look at Germany, they invest $36 billion. So we invest, quite a bit more compared to Germany on overall R&D. But they invest 6 times as much as we do in industrial production and technology, $4 billion. Now, Japan, they use 7% of their budget on industrial production and technology, whereas we invest 0.52%. So they invest, in actual dollars, they invest 3 times as much as the U.S. South Korea invests 8 times as much. So we should continue our investments in basic research. But we should also invest in this industrial production and technology, broadly speaking. Otherwise, you wonder why we keep generating knowledge but not wealth. The answer is right there. And the results are right there. Everybody else seems to have surplus, but we have big deficit. So if these countries that we should be benchmarking against, Japan, Germany, and South Korea, they're spending 7%, 12%, 30%, forget South Korea 30%, but 7 and 12% if they are spending of their budget on industrial production and technology, because they have a strategy what to do with the good ideas with R&D. Maybe should we spend at least 5%? Is that reasonable? So not just not just doing that, but creating demand, but not just supply. And if you look at, of course, the private sector does not take the nascent technology is too risky. And because of market and technical uncertainty, they are not doing long-term investment. So the government has to do that. Government has done it in the past. This is not nothing new. Even the recent example Professor Shea gave on the aircraft engines, going back to aerospace industry itself, semiconductors, computers, internet, GPS. This is all government-funded research and government early procurement. We've done it before. We can do it again. Are we really going to lead the world in those technologies, drones and electric vehicles and autonomous vehicles and flexible displays and flexible solar? I don't know about the last two. They're already happening in South Korea. So we need a strategy, a bold strategy. We need to close the gaps in our innovation pipeline. We put money in discovery in basic research, and rightly so. But you see, number one gap, leak in our pipeline is we have our academic researchers and others are taking their research and establishing labs in other countries. Again, no one to blame. That's where the demand is. That's where they are willing to invest. Sure, why not? So we are losing that. Many of our graduate students in engineering, over 60%, are foreign students. And many of them are going back. We are losing brain drain right there. Finally, when it comes to proof of concept prototypes based on all the inventions and patents that are sitting around languishing in our tech transfer offices, there's no one is investing, so we have foreign entities, and good for them. They are investing and taking them. Why not? We're losing that. And finally, when it comes to scale up, read the MIT study done years ago, and there's more. That's not happening here. You can do all the technology development you want. You're not scaling up. You're not manufacturing. And why should we manufacture? If you don't manufacture, we'll lose our ability to innovate. No wonder we are not making flexible solar cells and flexible displays because we abandoned manufacturing flat panel displays. And you saw some of the videos from Willie's presentation. So that's where the production know-how, manufacturing know-how comes in. So all the different agencies across we have great system, great agencies investing in maturing technology readiness levels, which is great. We have all those pieces in place. What's missing is the manufacturing readiness. That's what we need to do. So this is what actually the manufacturing community said as we went around and talked to folks. What do we need to do? We need to close the gaps in our pipeline, create demand, not just supply, and rebuild our industrial commons. We said, what does it mean? We got a little detail and then with a lot of ideas, and we consolidated them into 4 main critical next steps or recommendations, you may call them. Invest in translational R&D. Let me go through actually each of them in the next few slides. But the overarching strategy is, see, the fact that manufacturing cuts across multiple disciplines. They're making chemicals or semiconductors or bio or whatever, automobiles. It cuts across multiple disciplines and missions of different federal S&T agencies. That is why it's all the more compelling that we have a central focal point for manufacturing. And that is the key missing element. And now, what are the critical next steps? Invest in translational R&D. You can read in the report, but I'll just be very brief. Translational research centers. These are university-affiliated research centers, but they're privately run, staffed by professional engineers and professional business leaders. So take the ideas coming out of universities and take it to the next step and mature it so that you create the basis for hardware startups. And the other one is investing in manufacturing process research, process technology, systems engineering, maturing MRLs. And if some people will say, well, we are doing that. Well, if you're doing that, either you're doing a bad job, or you're doing a good job, but you're not doing enough. It's not scaled throughout. So we need some heavy investment. You're talking about a 5% of federal budget. It could be our numbers. People are talking about ranging from $5 to $7 billion of investment. And establishing additional manufacturing USA institutes, not only in emerging technologies, but more importantly on foundational capabilities. This is another good idea that thought leaders have suggested. In metal forming, in laser processing, in biomanufacturing, in joining technologies, broadly speaking, that cuts across all disciplines. So those are the kinds of foundational capabilities we need to build. And promote scale-ups and startups. One is leverage government procurement. Somebody said, who is the guy who got $115 billion on battery in a few years ago, the battery manufacturing went out of business. And of course, the company was sold to China. He said, if the government said they're going to buy the first 500,000 batteries from me, I could have taken that letter and raised $200 million myself. I don't need the $115 million. That is, government purchase orders are an effective tool to incentivize private investment. And also, we need some bright ideas on how to create public-private manufacturing investment funds for scale-ups. And empowering small and medium-sized, 98% of our manufacturers are small and medium-sized companies. And especially the medium-sized companies, we need to empower them. They're not looking for handouts. They need to be empowered in the ways that Willie talked about. In terms of, one of the things we could do is to simplify the licensing agreements between universities and these companies. And we need to, provide loan guarantees to incentivize the small companies to modernize their capital equipment. That's the only way this smart manufacturing stuff is going to trickle down. And it needs to trickle down to small and medium-sized companies because they are the backbone of our manufacturing base. And also, they never had the China plan to begin with. And we also need industry fellows. We have our retirees, engineering and management retirees are being moved to Asia. We can keep them here. They would rather stay here. And we need to have industry fellowships to help our startups in many other ways. And growing domestic engineering talent. So we can certainly provide, one way to do that is through graduate fellowships, so we have more of domestic students going into these fields, and through apprenticeship programs many of you have talked about, and providing educating engineering technicians. So these are the critical next steps. And we don't want to put Band-Aids. Let's pick two of these and put $100 million investment. Let's not do that. Let's not waste that $100 million. It's better to do nothing. We do close all the innovation gaps and do this, and if we are serious. So in summary, innovate there, manufacture there. I think that is a dangerous trend. Not only I think you all agree. It's a dangerous trend for a developed country. Being the world's best in science and technology is critical, and we should continue to be so, but not sufficient to compete in the global economy. The taxes, trade, and all the stuff going on isn't maybe necessary to enhance competitiveness of existing industries, but certainly not sufficient to create new industries of the future. And so the recapturing the global leadership requires long-term. That's one thing. The private sector sometimes doesn't have the long-term, and the public sector can't even think beyond November. So we need a long-term strategic and significant investment if we want to create industries of the future. And other countries are not sitting around, and really the burden is on us. So I'll stop here.